Happy September and welcome everybody. It's been a while since we've been on. I've been very busy, so have all of us, I'm sure. But instead of spending time doing videos, I've been spending time working on the railroad. But I'll give you an update today, and I think this update is going to be called Taking the Mystery Out of the Magic of JMRI. Nonetheless, this is going to be a talk much about a dispatcher's desk and how you put it together, and a lot of different ideas that go into it. While I said I wouldn't do a video on wiring because it would be boring, that doesn't mean I'm not going to talk about wiring and how to get it all to work together with JMRI so that you can have a dispatcher's desk. If you've been following on Facebook, you see that the panels have been built and a lot of different things. Also, I'll be giving a small preview of what's to come in the next couple months. One of the things, if you've been on Facebook, is you saw some scenery have come on board, and we're going to talk a little about that. Well, maybe not talk about it, but a preview of it. Also, one of the things that I always talk about, creature comforts in your railroad and setting the environment. I have a balance over top of my head. Living in Seattle, rain is just part of the lifestyle that's here. Having this allows me to at least open the door and stay dry a little longer, or get out of the rain, depending on the situation. But nonetheless, come on in, let's talk about what we're going to be doing and what's been going on, and we'll talk about dispatching and operations. Okay, so here we are at the dispatcher's desk, and you've probably seen this before because I've taken here a few times. Just again, to refresh your memory, Loveland is right over here just off to the side. The staging yard comes out from over here. This is, of course, the route between Loveland and Longmont. And sitting underneath here is my dispatcher's desk, which I can pull the desk out. I have lighting in here and everything, and that's kind of what I've got here. It includes these three monitors here. This monitor is kind of an important monitor. This is actually a live video feed of the staging yard. So this is the Pueblo throat, this is the Cheyenne throat, this is the Cheyenne corner, this is the Pueblo corner. These two videos here are midway. This is an overview shot going straight down from the south end pointing north, and this is straight across midway. This is actually, there's a line right here which you can't see, but as a dispatcher you can see, and that is the break between the two ends of the staging yard. The other half are these monitors right here, which this monitor right here is my staging yard. This is my CTC panel. These move, flex, so the dispatcher, while I'm short and I can just barely fit under here, this desk actually pulls out. You can bring this out so you can stand away and be very visible and have everything. And the light is out of the way, and that's kind of nice. The other thing is here we have a phone, and we'll get about that in a little while. I'm going to just push this all back in here so that you've got a broader view. The other thing I want to, there we go. The other thing I want to kind of point out is why we have a dispatcher. This layout is designed for operations. That brings me to a really important point. Operations. When you're designing a layout, you need to think about operations. If you're doing an operational layout or want to do an operational layout, you've really got to figure this out ahead of time. And that includes right from the very beginning when you're designing. Where is the dispatcher's desk going? How are we going to run trains? What trains are we going to run? What are they going to do? What's the purpose for this layout being here? What is the purpose for this train going from point A to point B? That all ties in to the JMRI and the mystery and magic of what JMRI is. So, the first thing you have to do is really take a look at what am I building and what am I going to do. Now, I cheated, or I used the prototype, which is exactly what I'm modeling is the prototype. I'm modeling the Colorado and Southern from Loveland to Colorado Springs. So, you know, I didn't have to really think too hard about how to do it. All I had to do is take a look at what did the railroad do. So let's take a look at if you're a freelancer. Well, if you're a freelancer, you're modeling a specific area. You know, whatever it is. I don't know. You chose it. But there's a prototype there that you can take a look at and say, how did they do this? How did they arrange the tracks? A lot of what I've done on this layout is exactly that. Looked at what they did, yes, compressed it because I'm covering 120 some odd miles, but I compressed it in a fashion that made it work exceptionally well. So, that being said, it's JMRI that ties the two parts together. The operations that I designed and how am I going to achieve that through my dispatcher. So, one aspect of it is I gave myself visible information that I can take a look at and I can actually see the train. So I know if a train is fouling the staging yard throat, or I can see what's going on. Another thing to take a look at, oh, I forgot this, and I think this is a really important part. It used to be thought that, hey, if you have an operational layout, you're doing pretty much point to point, which I agree. That's exactly what you're doing many times. You only are modeling a certain point, so it's coming from this point and going off of that point. But let's be fair about it. We have open houses. We have grandchildren that come over and visit. You have things in which you're going to want to interact with people. The advantage of the layout that I designed is that the staging yard folds back on itself. So the north end actually is the back end of the south. Thus the reason why I've got a point name Midway. It means that it's midway between the two staging yards. So I have a circle, so that if I have an open house or I have grandchildren coming on, I can run a train, walk away, and not even think twice about it. But when I'm in operations mode, I have a north staging yard and a south staging yard. They just happen to be a circle to complete. It's a double-ended staging yard. And that's the advantage of using a double-ended staging yard. Now I don't have multiple decks. I have one deck. But my staging yard sits on a deck that's underneath all my rest of my railroad. So as it comes out here from Loveland, it's climbing up a grade, up onto the grade of the layout. It goes through the whole layout, and when it comes over to Colorado Springs, it begins to go down and back into the staging yard. Really handy. And it makes it so that a train comes out, it does its job. Now my layout is a little more unique in the fact that Denver, a divisional point or a terminus point for a lot of railroads, is located in the middle of my layout. So a lot of my trains come out from the staging yard, go to Denver, and then turn around, flip around, and go right back out the same way they came. So they're going to come in with a train, they're going to drop off some stuff, and then they're going to probably go right back out the same way they came in. This is really true with my passenger trains. Many of the passenger trains that I'm going to be operating are coming out of the south end, going up to Denver. They'll go into the locomotive facility, get serviced. They'll turn the passenger train around. They'll then bring the locomotives back out. They'll restock the passengers, and away back down south they'll go. Freight, on the other hand, is pretty much point to point, from the north end going south or from the south end coming north. That's how my layout is designed. How are we going to achieve it? Well, we're going to achieve it through JMRI. So let's take a look at what we've got here. So one of the things you can do is you start up JMRI. And again, this is not going to be how to do it. This is just showing you how JMRI and the mysteries that are within it and what it accomplishes it. So I use Windows 10. I've used Windows 7. I've used XP for JMRI. They all work. I am personally, I kind of like Windows 7. I've been using 10 now for about 6 months, 7 months. I'm growing accustomed to it and getting used to operating within it. So anyway, once Panel Pro starts up, I'm going to come in here. It's going to ask me, I selected my railroad, the Colorado Front Range Railroad. I have multiple railroads in there because I do some other stuff on the side. But what I can do then is I can actually pull up my panels. And I've talked about it in the past that I have working in master. So I'm going to pull up my dual panels working. It'll start. So what you see right here is my staging yard is already being built here. This is all designed, and we'll go through what's different between this and my CTC board sitting back here. So my dispatcher from his position has complete control over the staging and the main line of the Colorado and the Colorado Front Range Railroad. Now when it starts up, you have the other thing I have automatically starting up. I have my Wi-Fi throttle starting up, which I'm going to minimize that right now. And then you have this master panel. We'll talk about that in a few minutes. But I want to go over the differences between these two panels. One of the things I talked about in the past was, feedback from turnouts. Well, after the last video, when John saw it, he said, why don't we have feedback? And I said, well, because I had a bunch of Octa 8s and I didn't see a reason to go buy something new. And John said, and what would feedback give us? Well, I'm going to share with you what feedback gives us because we went with feedback. Octa 8s are used on my staging. Now they're going to be changed, but right now that's what they're being used on the staging. And what you can see right here that nothing has been filled in. You see a bunch of question marks there. You may not be able to, but there's a bunch of question marks because it does not know the position of the servo. There is no feedback to JMRI. All JMRI knows is I can control these. Not a big deal because I've done this in the past. This is what I've used. And you can simply, to get them to respond, you simply set your layout up before operations and you just click on the question marks and voila, the servos are in those positions. They always start out in the normal position. So now the graphics here on this side is all telling me exactly the position of the staging yard here on the Cheyenne side. I can do the same thing over here on the Pueblo side. Just simply click and voila, those are now in operations. And from now on, JMRI is going to know what's going on. Now, downside of feedback. If you have a pad or you have Wi-Fi and you've given your operators the ability to turn turnouts, it is possible for them to switch these turnouts and my dispatcher not know, because they simply would type it into the DCC system, tell them to turn the turnout, and it would change, and you would have no feedback. That's the disadvantage of using something that doesn't have a feedback. It's working fine. My dispatcher knows exactly the position of it is right now, but if somebody changes something, there's no feedback. We'll get to feedback here in a minute. I want to focus on this staging yard. The other thing you notice is I have yellow flashing lights here. One of the things that John and me took a look at after we got done talking about, okay, let's do feedback. What are we going to do with these Octa 8s? Well, before I made Arduino servo control, well, they were relay controls. And we were talking, and I said, well, I don't see why we can't use the Octa 8s to do power control. That would then in turn get it onto my local net system, which we'll address that in a minute. So what I've done is we've changed, John, since we've last been in here, has gone and changed, taken out all those Arduinos, and now we have Octa 8s controlling it. And these are controlling the relays that are controlling the power on the track on the staging yard. So when I have an operations, or the plan is when I have an operations, we will have approximately 16 locomotives sitting back in the staging yard. Well, excuse me, 16 trains. I might have 32 locomotives sitting back there. That's a lot of noise underneath Denver just running because I have power on there. By putting in these relays that are being controlled by the Octa 8s, I can turn on and off the power from my computer screen. That's what I'm trying to do. Right now, currently, I'm using white lights, which happen to be occupied lights. We might change that because I'm going to put occupiers in there and a couple other things. So that's going to be something we're going to change down the road. But right now, I'm going to flip these switches, and you're going to get a split video of the relays being controlled. The neat thing is servos are 5 volts of power, and the Octa 8 can control that. And voila, I now have control over power over them. I can even control that main line circle there by simply clicking on those as well. And that's really cool because now I can shut down those 32 locomotives back there. And now I only have the noise just in the Denver area and only have locomotives starting up as they get powered up, as the dispatcher is ready to bring them onto the table. That's really kind of nice. The other reason why we want to put in block occupiers is because one of the features I can do on JMRI is I can have it detect a train, and through logic of I came in from this side and I hit this second circuit and this second circuit, thus my train's traveling in that direction, I can create that logic, and now I can have train markers up here. And one step farther, with RFID, I can actually assign an RFD so that when the locomotive comes in, and it comes in, it says this locomotive's here, and then it trips those occupiers. I can create logic in which now not only do I get a direction that the train is traveling, but I also get what train it is. That's what the magic of JMRI is. We're still a ways from there. We're still working on getting our occupiers put in there, but that's what we're using. Now, there's a lot of different products that can do that. For instance, my block occupiers are done by RR circuits. I'm not saying that they're the best. I'm not saying anything. I'm saying that's what I'm using because I'm familiar and it works for what I'm going to do. Now, uniquely, one of the things that I'd like to point out is by turning off the power in this area, I have a unique situation because when the power is off, our circuits can detect current going through the block. If I turn the power off, there's no current. So we would actually then in turn flag this area as there's a locomotive not there anymore, and it would be unoccupied. So I'm debating between two different ways of doing that. Writing logic that says if the power switch is switched on, then you can give it a detection. Otherwise, you don't have any detection. So I'm trying to figure out how best to do that. I might, the other option is I can use, instead of using current detection, I could use an opto, in which case light's being shot across the beam. Hey, there's a train in the way. Now I get a trip on this. It's a separate circuit. Kind of debating that through still. Haven't worked that one out yet, but those are my two options that I'm looking at. The other thing I use Tam Valley's LNS, Quadra LNSs. Now, I've used Tam Valley before, so I went to Tam Valley again. Again, there are other products that are out there. I personally like Tam Valley. First of all, I like Duncan McCree because I can type Duncan a message and I get a message back, hey, Mike, you can do this. Yeah, you can do this. Because I sometimes come up with some crazy ideas. I need to bounce it off of Duncan and say, can I do this? And Duncan oftentimes says, oh yeah, if you do this or this, or yeah, Mike, you can do that. No problem. It will handle that. And that's exactly what I like dealing with Tam Valley, because their versatility in their product. So while I'm not using the Octo 8s for servo controls on the layout, I am using them for the ability to turn on and off power. So that's kind of nice. And besides on and off power, it cannot be controlled from any other location. You can only control it from this location here. So I don't necessarily need feedback. Although, yeah, there's a way to lock them out of that. I can lock people out of any of these products too. So that's kind of nice. I can just lock them out and say, no, you can't control it. Only this board can control it. So that's kind of nice. So that's kind of how this is working right here. Now, what's different on the CTC panel is I have feedback. If you noticed, when this one started up, immediately all the lights are lit up and all the graphics are correct, because what's happening is JMRI goes out and says, hey, what position are you in? And it comes back and feeds back and says, I'm in this position. And immediately my CTC board knows exactly what's going on. Now, while I'm going to lock the operators out when we're running operations, let's say I'm sitting here and I'm working on something and I've got a pad and I'm working on the actual switch itself. I might be flipping here and then coming back over here, and then I decide to run a train. I have flipped it over there. Well, anytime a turnout gets flipped on this system, it gives feedback to this panel. So this panel is telling me exactly the positions that are in. Additionally, if I flip a turnout, I'll take this one right here and flip it, you will notice that these two lights will flash red, and then this position will give a question mark, and then it will go into the position it's in. That's because it's in the feedback coming from the decoder is saying, hey, I'm not in either the normal position or the thrown position, I'm in another position. And so JMRI is giving me that feedback. So there it is, both red, and then it flips to the yellow. That's more like exactly what you would see on a CTC panel. Granted, delay is much longer, but everything's compressed, so it'll work fine. And games we play. Anyway, that's kind of the situation. You can see up here on the panel you get an X and then it comes back to the position it's thrown in. So that's really kind of nice. The other thing that I want to show you is the fact that I'm a huge fan of LCC. Layout control is going to be a really interesting feature coming in the future, but it's not here today. I use EasyDCC. Now, I'm not saying that NCE or Digitrax are bad products or anything. It just happened to be when I got into DCC, I went with EasyDCC. I happen to like the product. I like it an awful lot, and I think an awful lot of it. The advantage of it is that it's really good at controlling trains, and that's what I want it to do. So on my layout, EasyDCC just controls trains. The advantage of that is I've eliminated all the data. LCC is not here. You can imagine with all the feedback and all the stuff that I have going on these two panels alone, plus running multiple locomotives, when the time comes and you want to hit a horn and it delays, that's not what you want. You want it to be hitting the horn and operating exactly as you can see it. Now granted, it's only milliseconds, but it's noticeable as we as humans were used to certain things. When you pull that cable, you're opening that valve, you're expecting that horn to sound. And that's what we're expecting on the layout too. So to compensate that LCC is not here today, I have a dual DCC system operating. So I'm using EasyDCC for just controlling trains. Over here, I have a Zephyr system from Digitrax, in which is running my entire local net. The local net just runs the layout. There is no other data that's going. There's no throttles on there. There's no nothing. All it's doing is controlling turnouts, signals, and sensors. That's all it's doing. And so it manages, by this format, I get good response from both my layout control side of it and my train control side of it. So I can run and operate just as if it's normal. Now that may seem excessive and expensive, but let's be fair about it. I bought a Zephyr and I bought an interface, and voila, that cost me, okay, 200 bucks. But that's 200 bucks of not having a headache that makes it worthwhile to me. And that's what I'm trying to do. How can I make this layout work exceptionally well? And that's the goal. The goal is to make this operations work smoothly so that people want to come and operate on your layout. So that goes back to what we were doing with a lot of Digitrax and a lot of what's going on. Octa 8s are not the easiest thing in the world to program. That's not a fault. It's just a simple, inexpensive method, and it's not as easy. It's not as robust. The hardware was not as robust. The LNSs are really robust, and let me show you. And you're probably sitting here saying, oh my gosh, all this program is really tough. Really, it's not. The unique thing about JMRI is that if it's a decoder, it goes on a roster. And so I'm going to pull up Decoder Pro. So here I am. I'm going to pull up my roster, which, voila, these, my servo controls, are on my roster. And so everything gets stored into here. And that's the magic and the mystery of JMRI. Everything's all there. All I have to do is just attach these things to whatever I want to do. So, nice thing about these is that I can program their decoders into the thousands. So in the case of this, LocalNet, this turnout, this decoder here for these 8 servos are programmed to decoder program 12,002. That's really nice. And it tells me it's controlling turnouts 9 through 16. Labeling is an important part of this hobby. If you're not organized on your wiring, you're going to have a mess. Now that's not to say that when we wire things together, we don't have wires hanging down all over the place while we're working on it. But once we get it fixed, we've got to go back in and clean that up, because I guarantee you 4 months later, after you finish the project and everything's done, and all of a sudden something's not functioning, you're going to want to find out how to do that. And I'm going to show you a little of our demonstration of how we organize our wiring so we can figure this out. I'm going to show you examples of our rat's nests that we have, and then how we clean them up as well, so we can trace those wires back when we need to. It's really important, because if you want to troubleshoot, you got to be able to find wire A and wire B and figure it out. One of the things that we do is on my servos, I got one sitting right here, we tag them. And this one doesn't have a tag. And that means I got to get a label on here. So what I do is I tag the servo connection on this end so that it's already got a number on it. So in the case of this one, this is 39. So I need to have a tag on here that says 39. Reversely, where they feed into the cards here, because I have big long extensions and these are sitting maybe as far as 10 feet away, I need to be able to have that wire tagged on this side that says this is 39, so that I can figure out exactly what servos are in what place so I can troubleshoot it. And that will help you in the long run. You want to make your hobby fun? Unfortunately, being a little organized is part of the game. But nonetheless, let's take a look at some of the programming for this. So I'm going to select this LNS here, and I'm going to pull it up. And this is really what makes this really unique and really a robust product. What I've got here is the entire programming for this card. I literally just have to check. So here is the address. I simply enter the address. I then tell it when it's plugged into the system, and when I do that, I program this separately. I actually disconnect the Digitrax from the rest of the layout and plug it straight into here, so that when I say program this decoder to this address. Now I don't have to program these every day of the week, so I don't really see a need to set up a separate programming system. I just simply disconnect it, plug it into here, and say program it, and it works fine for me. You get to choose how you want to do it. But if you already have a programming track and you have a way of connecting the local net programming into there with Digitrax, you guys are using it already, you know what you do, but that's how I do mine. So I simply enter that into that value there. I then go into here and I give it, I tell it what servos it's controlling, I tell it what's the starting address, what the ending addresses are, what kind of delays I want on routing. I can tell it, hey, I only have 4 servos on here and I'm controlling 4 LEDs. Or I'm controlling 8 servos and no LEDs. Some of the advantages and variations that you can have with this. And then literally I have here programming for each and every last one of the servos, and I can control where its start point is, where its finish point. And I simply sit in here and I'm controlling it step by step by step until I get exactly my turnouts to hit exactly where I want them to be. Now, they're not stepper motors. These are servos. If it was stepper motors, it would be much more precise. But servos do the job very well, and they work exceptionally well, and they will function doing exactly that. I can get them to the point. So that then sets my close point and my throw point, and those numbers that are in there after I've set that up are the numbers that it's saying, hey, I'm in the close position, hey, I'm in the thrown position. You don't have to do anything else. Just set the turnout to work the way you want it to, and guess what? It does exactly that point. And there you go. That's it right there. Then I simply tell it, hey, I want feedback, and I want my feedback to be the exact feedback. So it's going to tell you, hey, feedback, it's being designed and it's being feedback the exact position. So if it's in the close, it says, yep, I'm in the close. It's in the open, it says, yep, I'm in the open. And if it's in any other position, it says, hey, I don't know where I'm at. And that's all it's doing. So that's what we want, and that's what we want to do, and that's what feedback gives you. So I think that's kind of nice. So that's kind of how JMRI is controlling everything, and that's kind of the mystery of the magic of what you can get out of this. Because I can create all these different controls, I can get that feedback and get live. Now the advantage also of feedback here, one of the other things is if I'm in that mode and you hit it on the throttle, it feedbacks to this layout, and my dispatcher knows, hey, this turnout's in the wrong position. Now let's take a look at what I've got. One of the points that I have in here, you see here in the Denver area here, I have a branch line that's crossing the main. So to cross the main, that local has to give a call on the phone system, which here's my phone numbers right here. Here's my phone system. You actually dial it and you call. You would call the dispatcher desk and say, hey, I want to cross the main. I want to get to that branch line. Now, my CTC panel doesn't control that crossing. It's a local control. So what do? You have to call, tell the dispatcher what you want to do. The dispatcher says, yes, you can go ahead and do that. You'll then turn a key, which will lock out the main line and turn on red lights on the red line. When that occurs, that's going to give feedback to my dispatcher panel that's going to say, hey, I've got red lights on the main line, I can't cross there. Now CTC can't control that portion of the layout because it's being controlled locally. But they had to call first to get permission to do that. They then cross over through the crossing, and it's a diamond crossing. So the turnout is controlled here by, see there's that mutual exclusion. The turnout is controlled by CTC panel, but the crossing lights and lights aren't. So if you want to go across there, you have to call CTC to say, hey, I want you to turn this turnout. And he's going to say, well, why do you want to turn it? Well, I need to get on the branch line. Okay, so you're going to use the branch line. Yes, I have a clear spot. You can go ahead and cross the main. He will flip the turnout. They will lock the lock that will lock out the main. They then go across that thing. They get their train across there. They unlock. They lock it back up. The panel will go red, and they can call CTC saying, yes, we're cleared, and now he can continue to dispatch as normal, just as the real railroad works, and that's how it works. They would then go on the branch line and work their job, and it's a dark area. Absolutely no control whatsoever on the CTC panel. Pretty cool, huh? That's operations. That's how this works, and that's what we're trying to do on this railroad. So in any case, let's take a look at some of that boring wiring and show you some of my rat's nests and how we clean it up. Well, here we are at one of the power stations or power panels I have on the layout. I actually have 3 power panels on this layout. This happens to be power district number 2. The other one is number 1, which controls the main line and basically from Denver all the way down to Colorado Springs. And then this one controls from Loveland all the way up to Denver. The third panel is the staging district panel, which you saw earlier with the flipping relays and all that. And each one of those panels, we have some basic components that we actually have on location here. For instance, we can tell what our output on voltage is and how many amps we're drawing. We have in here our circuit breakers for the layout itself, and I can't emphasize that amount. You do not want to damage your equipment. Now I have 10 amp DCC power boosters in here, but I'm broken them down into roughly 4 volts, 4 amps a piece, and that basically ensures that I keep my equipment safe. These are designed to trip whenever a short comes out, a long short. And you can see we've got it broken down. The power comes into here. It gets broken through this location into the circuit breakers, and then it comes down here and feeds out. And then we've got labeled on here. This is the Longmont yard. This is Longmont. This is the Loveland to Longmont line, and this is Loveland itself. So we can actually come in and trace. So if we have a problem with anything, we can come in and find it. This little thing right here is an experiment that John and me were working on, and that's working with the Watchman. This Watchman right here for block occupiers. And basically what we're doing is trying to see if this would work to tell us when something was in the power district or the sub-districts with the locomotives. The issue we ran into is that we use frog juicers, and of course when we use frog juicers, lo and behold, those draw current, and it was causing a trip of the circuit. So what we end up doing is we're going to take these CT coils and we'll actually put them into each of the downs, actually two, one on each end, to detect the locomotive when it comes in and where it's going, and that'll help us give us directional control as well. Speaking of power, this is really important. You can buy these. I got sitting up here a cheap 12-volt power supply they get from China. Now, that's taken a lot of power, and I don't want all that power just running raw and rampant and possibly burning up, you know, boards and cards and things like that. So we put fuses on each of them and we break them down. So those fuses actually break down into a couple different supplies. Here we've got two fuses. These fuses are 4-amp fuses. That's all they are. That's all we need. That's more than enough power to power any of our decoder cards, our circuit, our frog juicers, or any of the other things that are in there. And so that's kind of one of the things that when you're building these layouts, especially a large layout, if you've got a small layout, you don't need as many of these things. But if you've got a small one, a large layout, you need to break your power down so you're not getting so much power going into certain areas. The other thing is I've removed my refrigerator back in here, so just to kind of give you an idea, whenever you're building your layout and whenever you're doing your wiring, the one thing you want to be able to is to get to what it is that you're working on. The reason why we have these power panels here is that these help us with distributing the power to where we need to go. It also helps us so that when we troubleshoot, we can simply deconnect the certain areas and we can actually work on just those areas if we have a short in that area there. But once we get in here, and I'm going to show you some photographs, these are rat's nests. I mean, behind this thing can really become a real rat's nest. And what you need to do is, once you've got everything kind of wired, you need to kind of sit down and gather the wires up. So I'm going to show you a photograph because it's really hard to get the camera in there and all the lighting and everything. But we'll get that in, show you a photograph. Here it is right here of what this looks like after we're done working with it, when it's all cleaned up and we can trace the wires. So this wire goes to here and this wire goes to here. It's really important when troubleshooting because things go wrong. If one thing I'll promise you on a model railroad is things will go wrong. They always seem to go wrong because that's just the nature of model railroading. So you want to be able to get your wiring. The other thing you might do, I buy these ties right here. These actually are little boxes that you can stick up underneath the panels and things like this, and then you can put a zip tie through there and zip tie them shut. And voila, now you can bundle your wires into a group so you can trace them down. So I actually have these throughout the whole thing. Some of them are used for things like, the servo lines, so I can keep track of them. I don't need those servo lines gathered up and everything, especially with my DCC line, so I keep those separate and kind of twist those a little bit as I go down there so I don't get any other things. And then we have lines like we have the serial line for the local net, as opposed to just the telephone wire. There's two different types of local net wiring that you can use. And we use serial and the local net telephone type wiring. So those, it's 6-strand. But those we use and we can gather them up so that when in turn, when we're kind of working with different things, we can just follow it and trace down where it's at. But the key thing is to have labels on everything. Everything's labeled. To also help, we've got color coding. So Longmont, if I see a green and white wire together, I know that that goes to this particular block and to this circuit breaker and to this power district. To help us out, we're using LocalNet, using Digitrax circuit breakers, and one of the things is each one of the power districts has a number on them. So this is 2. So 2, 1, 2, 2, 2, 3, 2, 4. On our monitoring system back there, it reports back to a short to the dispatcher's table. So we can pull it up and say, oh, hey, we have a short in block 2-1. We can come right here to these panels and go 2-1. Oh, 2-1's Loveland. I got a short in Loveland. I got to go figure out where that's at. The rest of the railroad isn't down. I'm only dealing with a short in Loveland. And it's kind of helpful all the way around. So anyway, that's my wiring video. And now I'm going to give you a preview of what's coming up in the next video, scenery. I know wiring's kind of boring. but I thought this might be interesting and helpful for those of you that are out there. So in any case, let's go take a look at some scenery. So here's a preview of what I'm going to be working on the next video. This is this shelf area here is from Loveland, which is back there, that mass that you see back there, going all the way up to Longmont over here. This is a single track main line running through, basically, as you can see, prairie grassland. So I'm going to just kind of go over making prairie grassland. If you take a look at this, you can see that there are some dark spots and some light spots and some bare spots. When you go out to the prairies of Colorado, this is very common, and you're going to just kind of create this thing. One of the other things you see, there's some of the grass down here that you can't see because it's so far away, but there's some grass that's laid down as if animals have been laying in that area. That's exactly what you want to do and create. But you can't just use it with just one static grass product. And I'm going to go over how I mix my grass and how I get what I'm looking for and the steps that I go through. If you may have seen on the Facebook page, this trestle bridge here I built, you can see the photographs of it on the Facebook page for the Colorado Front Range. And also, this will be a river back through here. And this is not it's a very small river, but it's a typical of the Colorado area. And that's a lot of what I'm going to be doing here. So the next video is going to be on scenery and kind of how I've gone about doing some of this. In any case, until next time I speak to you, happy modeling and have yourself a great month.